This video is for all my subscribers and other people who have concerns about using their cell phone due to microwave radiation. What I'm going to do in this video is we're going to do some testing to see what kind of radiation is emitted and ways that you can block that radiation. Now before I get into that, I'd like to show you exactly how this meter works. Now the different ranges that are available are magnetic, looking for electromagnetic, looking for electric fields, and looking for radio waves or microwaves. That's the settings that are available on this meter. Now what the meter is looking for when you put it to the magnetic setting is current that is flowing. This is going to show you that current that is going through the circuit. Now what I'm going to do is give you a simple little demonstration using direct current, showing how once the circuit is completed to this 3 amp light bulb, this incandescent lamp, you're going to see an electromagnetic pulse showing up on this meter. Now because it's not alternating current, you're only going to see the initial pulse. You're going to see the scale jump up when that pulse of electromagnetic field is generated. So I'm going to go to the bulb, touch that to the other side, and you're going to watch the meter. Here's the spike when the light comes on. Now if you keep touching it quickly, if you keep going like that, you're going to see it's simulating alternating current, or pulsed, and it's keeping the needle all the way to the right. So this range is looking for current that is flowing through a circuit or through a wire, and that's how it arrives at the electromagnetic setting. What I'm going to show you now is how when current flows through a wire, you can actually see that magnetic field that's created if you have a powerful magnet. Now that's a copper wire. As you can see, there's no effect with that wire. There is no current flowing through the wire. Now once I connect that wire to the bulb, that's going to change. You're going to have a current flowing through which is not alternating, so you're not going to have a changing magnetic field. You're going to have a constant magnetic field, either north or south, and the magnet is going to show you that by pulling the wire towards it or away from it, depending on which pole is facing towards the wire. So right now I'm going to connect the light up. Alright, the current is flowing through the circuit. I'm going to bring the magnet next to the wire and watch what happens. It's pulling towards because there's current flowing. Now if this was alternating current, the wire wouldn't be doing that because the polarity is switching back and forth, and you probably would just have a little vibration in the wire when you do that. Since we're dealing with direct current, the pole stays the same, as you can see right here. Now if you put this over to the electric field, what this is looking for is a voltage. That's all it's looking for. It could be lightning. You could go to turn on your gas stove and the igniter would actually make this jump because of the voltage. Or you could take this and position it next to a wire, in this case feeding my drop light. If you position this right next to the wire, you can see it's detecting right there. Alright? So it's detecting that electric field. The last setting on the meter is looking for radio waves or microwaves that are being transmitted. Now when we check the cell phone, you're going to see there's going to be a very small electric field coming out of the cell phone. There's going to be a large electromagnetic field being generated by the current flowing through the tank circuit to power the antenna. And then you're going to see the actual signal coming off of the phone, which in this case will be the microwaves. So let's go check it out. Now to get started, there are 2 types of cell phone systems that are in use. One is GSM and the other is CDMA. Now AT&T and T-Mobile likes to use GSM, which happens to put out a lot more radiation than CDMA, which is used by the other carriers. What I'm going to do is I'm going to use this old Nokia phone. This is my travel phone and my experimenting phone. This is on a GSM system. This is going to be the higher radiation output of the 2 systems. We're going to take a look at the outputs on the electric scale and the magnetic as well as the microwave. We're going to be testing different types of shielding materials to see what kind of an effect they have in reducing the radiation output from the cell phone. Now I have this type of material here. This is a specially designed fabric. One side has an adhesive on it. You can iron this onto something and it effectively shields out microwaves. We're also going to check out copper mesh, fine copper mesh screening like you see here. You can barely see any holes, it's so fine. This you can get at a craft store. We'll try some aluminum foil. We're also going to try this lead-lined film shield bag to see what kind of an effect that has. Alright, the first test we are going to perform is going to be to check for electric fields coming out of the phone. Now for privacy reasons, I blocked out my screen so the numbers aren't going to be shown. I'm going to dial my house and then we're going to take a look at the readings that show up on the meter. Alright. The needle's moving very, very slightly. It's just shaking. There we go. So the electric field is kind of low on the phone. Not too much of a concern. The antenna on this phone is located right here. And if you have an iPhone, it's the band that wraps around the phone. That's the antenna. Now if you were trying to block an electric field, it would be as simple as taking a copper screen or a piece of aluminum foil or a copper foil and just connecting a wire to it and then connecting it to the ground of the phone or whatever other electronic component you want to shield. As long as that wire is connected to the ground, it should block the electric field. Right now we're going to check for microwave. That's the bottom scale. If the needle goes to the right, that's going to indicate microwaves. So let's give it a shot. There you go, pulsing away. That's full scale. It's not good. Let me move the phone. Alright, the phone right now is like about a foot away. And as you can see, it's still cranking away. Let's put this here. Let me shut it off now. Alright, so now we know the microwaves are coming out. This time I'm going to try it, and we're going to try different shielding materials to see which one is the most effective to block out microwave radiation emitting from the cell phone. So let's give it a shot. There you go. Now, this is the one that's sold specifically. It's very, very thin. That brings it way down. Now I'm going to switch the aluminum foil for the microwave protection. Let's see. And that works well too for shielding the microwaves. Let's try the copper. Copper works the best. Lay that right over. And this is the original sheet. Let's try the lead-lined bag. Slight wiggle. Now we're going to take a look at the magnetic radiation coming off of the phone. Let me push that and that. Alright. That's not doing much. What if I fold the phone in it? Nope. Now if I wrap the phone in this, it will lose signal completely. This stuff will block it right out. Let's try wrapping it in copper. It's still there. Now we're going to take the phone. We tried wrapping it in the copper screening and this material here, and it had very little effect on the magnetic radiation. So the last thing I'm going to try is to take this film bag, it's lead lined, and I'm going to slide the phone inside of there. And when I do that, the phone will not be able to operate anymore. It's inside this lead-lined Faraday cage. No signals will reach the phone and no signals will exit the bag. But let's put the phone in there after I get it ringing. Let's see when I put it in the bag if it stops. In the bag with the end closed. So now you know you can block microwave radiation if you're concerned about it by purchasing a material like this for shielding your phone or whatever else you would like to shield. Or you can go pick up this very fine copper mesh screening at a craft store. Both work well. The aluminum foil works almost as good as the shielded material. And the lead-lined bag works well too, but it's just a little too heavy. If you enjoyed this video, please rate it a thumbs up, subscribe, and post links to this video on other websites and blogs. Also be sure to check out my video playlist as well. Thank you.